And here's an example of how to find the range of a projectile when it's shot from the ground at an angle of 25 degrees with initial velocity of 30 meters per second. And in the previous example where we used the general approach, we came up with the equation that r, the range, is equal to the initial velocity squared times the sine of twice the angle divided by g, when g is a positive 9.8 meters per second squared, just the magnitude of g. And yes, we can use that equation, and we'll go ahead and do that. But I'm also going to show you the general approach of how to solve projectile motion problems in the first place. And the reason why I do that is what I find is that when we try to memorize all these various different equations of projectile motion, they all get kind of confusing and you can't remember them, and it makes it very difficult to do the problems. If you have it handy, by all means, let's use it. So quickly, let's go ahead and use it right here. So we have 30 meters per second, so that's 30 squared times the sine of 25 degrees times 2, that would be the sine of 50 degrees, divided by g, or a positive 9.8, and that will give us an answer of, let's see here, we have 50, take the sine of that, times 30 squared, divided by 9.8 equals, and it looks like it's 70 meters, so the range equals 70 meters. But let's say you don't remember that equation. Would you be stuck? And the answer is no, not at all. We go ahead and use the same approach as before. We first find the x and y components of our velocity. So we have v initial in the x direction, which is equal to v initial times the cosine of theta. And we have the v initial in the y direction is equal to v initial times the sine of theta. So in this case, v initial, that would be 30 times the cosine of 25. And here that would be 30 times the sine of 25. Notice I left off the units. It's a little faster and a little cleaner. So let's go ahead and see what the answer is here. We have 25, take the sine and multiply it times 30, and we have 12.68. So 12.68 meters per second. Notice that I keep an extra few significant figures so I don't have any round-off errors. And on the x direction, the cosine of 25 times 30 equals, and it'll be 27.19. So that would be 27.19 meters per second. So now that you have the x and y components of the velocity, the next step would be to find time in the air. That's still the standard way of solving these problems. So time in the air. And so here we have that y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared. Notice that in this case, both the final and initial height is 0. So we have 0 equals 0 plus, in the y direction, 12.68 meters per second times time minus 4.9 t squared. Then we solve that for t. That's a quadratic equation. We can solve that by factoring out a t. So 0 equals t times 12.68 minus 4.9 t. So either t equals 0 or this quantity equals 0. 12.68 minus 4.9 t equals 0. Of course, if that's equal to 0, we can say that t is equal to minus 12.68 divided by minus 4.9, or the time is equal to 12.68 divided by 4.9 equals 2.59 seconds. All right. So now we determine time in the air. Now we can find the range, because we know the range is x, which is equal to v initial in the x direction times time. The initial velocity in the x direction is 27.19 meters per second. Multiply times the time that we got here of 2.59 seconds. And hopefully we get the same answer that we got over there. So let's find out. So times 27.19 equals, and sure enough, again, we get 70 meters, which is the range of the projectile. Now you may say, why in the world would you want to do it like this when you can do it like this? And true enough, you know, if you memorize this equation, by all means, go ahead and use it. But what if you don't memorize it? What if you can't quite remember if it's sine of 2 theta or sine of theta, or was it the cosine, and just forget? This way, you can always do it, and you hardly have to memorize anything. All you have to do here is find the components in the x and y direction. Time in the air, you always use this very same equation. Plug the time into this equation, you get the distance. So either way, get the same answer. and whether or not, so it's kind of a choice between doing a little more work and do it like this in the standard way, or just memorize more equations if you can, and then you can go ahead and do it that way.